I'm going to show you a tool called Data Explorer. It allows you to visualize data. It's an application of human-assisted AI. So there's this fallacy that we're going to run lots of algorithms on all this data and the world's good and we produce our scenarios and our training data. It never works like that. You have to visualize. Now, often what happens is people over the past few years have tried to create these tools themselves. I recommend you don't. I recommend you go to off-the-shelf tools and get yourself off the ground quickly. And I'm going to show you an example of that. We're going to use new scene data. You may be familiar with this. It's public data, real test drive data from Boston, Singapore typically, urban environments usually. Range of locations, times, weather conditions, things like that. Your usual stuff, right? And as I say, there's no metadata. So this is raw data. So there's no enrichment, there's no tagging, no labeling. This is pure image taken from the far edge, ingested at the station, brought back to the data scientist. I'm going to switch you across to my colleague Bhavya to give you a demonstration of that.
Thanks, Robin. So we'll begin by visualizing the new scene dataset, which we just spoke about. And from the very outset, the system is going to create a 2D point cluster, which is defined as a cluster map for us. All this really means is that it's a grouping of similar images into broad patterns. For example, one cluster could represent daytime driving, another nighttime. So if we had to focus on a specific point, using the KNN feature, we can see the 100 nearest neighbors, i.e. the most similar images to the selected one within the purple cluster. So through the selection feature of the Data Explorer tool, we can very quickly get the big picture of a big dataset at a glance. But if we had videos, for example, this is a dashcam feed from a police car chase, we get a time-based cluster map. So that indicates clusters based on a change in scene. This particular outlier represents the end of the police car chase, which is quite different to the duration of while on the road. Returning back to our image-based dataset, if we're to focus on a specific scenario to find that relevant data that the data scientists need, let's take the crosswalks example that Robin was mentioning. So we can give a thumbs up to our desired image, and we can take one more with a pedestrian on it and head to our visual search. So the searching that's going on in the background here is based on a feature vector search algorithm. That means there's no prior knowledge, no metadata. And as you can see, we've got images of crosswalks, just as we intended. But if we want to get even more specific and focus on the risk scenario here, that is pedestrians on the crosswalk, we can use the patch tool. This allows us to create a region of interest in case the item we're looking at, which is a pedestrian, isn't represented strongly enough in the feature vector to begin with. So the patch tool really allows you to build a clean data set. A cleaner data set gives you better models, better algorithms, and ultimately a better system. This, again, is avoiding all the traditional methods of labeling, metadata, prior knowledge, which take time, effort, and computational power. As you can see, we've got much more representative images of pedestrians on the crosswalks. If we already knew that that's the scenario we wanted to go for, we don't even need to go through this whole process. We can head straight to a very powerful text search. And just to make it even more interesting, what happens if we throw an animal into the mix? Yes.
In a conference, someone challenged us to try this, so we try things.
So as you can see, the system has been able to find pedestrian on a crosswalk with a dog, which is, if you think about it, really quite fantastic because it's very, very specific, especially if you have no labeling of the objects in this image. So in just a few minutes, we can get to that 1% relevant data that you need from a 34,000 image data set, which really isn't a lot if you think about the scale of autonomous driving data sets. Thank you. I'll hand back to Robin.